Hey, welcome back. Today we're going to talk about equations of lines as another part of our Algebra 1 review. We're going to find equations of lines in multiple forms given different properties. So here are the different types of equations that we can work with. We have slope-intercept form. This one is probably the most popular one that you did in Algebra 1. If you know the slope and you know the y-intercept, or where it crosses the y-axis, you can use slope-intercept form. If you have point slope, if you're given a point and the slope of the equation, then you just have to plug in your x and y into this formula, and then of course the slope in here, and you got yourself point slope. Standard form is one that we would use if we want to convert from one to another. As I'm comparing these, I really just want to look at my equations, right? I have slope-intercept form, y is by itself. Here, y is not by itself, it's got a number next to it. These two are very similar to each other. We could always convert this one to this one. And then from here, we can convert to standard form. What you would do is you would group the x's and the y's on the same side. Anyway, if you want me to show you how to do that, I can create a video. Just comment below, and I can show you how to convert between one form to another. All right? So let's do a couple of examples of each of these notations, and given different properties, let's see if we can come up with some equations. So here we want to write an equation in slope-intercept form. Why do we want to use slope-intercept form? Well, because you're given the slope and the y-intercept, right? So the general equation for slope-intercept form is y equals mx plus b. And I'm going to write this here in the center. Okay, where m is the slope, I'll put it up here in the top. M is the slope and b is the y-intercept. So if I have the slope, I would just have to plug it in here. M goes in here, and the y-intercept goes in here. And just like that, we have y equals 2/3 x plus b, or plus negative 10. Now, adding a negative is really just subtraction, so you can just say y equals 2/3 x minus 10. In this second example, we have a slope and we have the y-intercept in a point notation. The y-intercept will always cross the y-axis, so the x value will always be 0. So here our b value is negative half. So we have m, we have b, we just plug it in. So we have y equals m, which is negative 7/9 x plus b. Adding a negative means subtraction, so we have y equals negative 7/9 x minus a half. Now, as you're looking through these examples, we're going to want to be able to graph it. What does this look like when we're trying to graph stuff? Okay, if I'm trying to graph this equation on the first one, I notice that the y-intercept is at negative 10. So I would start at negative 10, and then the slope is up 2 over 3. So from here, I would go up 2 units and then over 3. Right? Up 2 units over 3, and then your slope is positive, so this line would be increasing in this direction. I'm trying to draw this line, sorry. So the line would be increasing, and it would start at negative 10 with that slope. This other one, you would start at negative half, so somewhere here, negative 1/2. And then the slope here is negative, so it's going to be pointing downward. And you would go down 7 over 9, down 7 over 9. For these, we're trying to find the equation in point slope. The reason we want to use point slope for this situation is because we are given a point and the slope. Here we don't know the y-intercept, so we cannot go about it that route. We can't go about writing y equals mx plus b because we don't know b. Instead, we're going to use this other form, y minus y1 equals m times x minus x1. Okay, I'll keep this one here in the center because it's a little bit longer. Okay, this is the notation that I want to use. As long as we know that m is the slope and x1, y1 is the point that you're using, Plug it into the formula, and you've got your solution. So here we go. I'm going to first start by labeling this my x1, y1, and I can plug it into the formula. So I have y minus y1, which is 6, equals the slope times x minus x1. And x1 is 4. There's your formula. That's really just it. How do we graph this? Well, you would go to the graph and you would find the point 4, 6. Right? You would find the point 4, 6. And then from there, I would find this slope, up 3 over 2. So you would go up 3 over 2, or down 3 over 2. And you have yourself that line. Right? Use the slope, use that point, and you got yourself your picture. For the other one, we have the slope is negative 7/5. So I have y, let's label these points x1, y1. Right? Y minus y1. Y minus negative 2 equals the slope times x minus x1. Subtracting a negative means addition. So here I'm going to change this to plus and change this to plus. Minus a negative means plus. And there's my formula. Y plus 2 equals negative 6/5 times x plus 5. So again, if I wanted to graph this, I would go to the graph, locate the point first, negative 5, negative 2. That's negative 5, negative 2. And then from there, you're going to have a negative slope. So you're going to go down 6 over 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. On the axis. And then I would just connect these points. Sorry for my not so straight line. Let's do that again. Okay? So point slope, you're given the point and the slope. The other one we were given slope and the y-intercept. All right, now from here, we want to write these equations given the graph. We're going to work backwards. If I give you the graph, can you find the equation in slope-intercept form? Slope-intercept form has the slope and the y-intercept. So the formula is y equals mx plus b. Okay, I'm going to keep this up here so we can reference it. Y equals mx plus b. So I need to find the y-intercept and I need to find the slope. Let's start with line B. I'll do this one in red. Line B is going to be over here. So for line B, I have y equals mx plus b. The y-intercept is down here. 1, 2, 3, 4, 5. Negative 5 is the y-intercept. Okay, so I can replace this right here with negative 5. The slope, I would count the points. I go up and over. The slope here is going to be, the rise is 3 over 1, 2, 3. All right, 3 over 3 is your rise over run. So I have m equals, the rise is 3, the run is 3. That simplifies down to 1. And we said that the y-intercept was negative 5. Now, the slope is going downward, right? Since this line is decreasing, the slope has to be negative. So I need to make sure that I include this to be a negative 1 as a slope. So my equation turns out to be y equals mx, which is negative 1x, plus b, which is a negative 5. And there's your formula in slope-intercept form. Let's find it for line C now. Line C is, I'm going to change the colors here in red. I need to find two things, the y-intercept and the slope. The y-intercept is already here on the y-axis. That's going to be 1, 2, 3, 4. So the y-intercept is 4. And the slope, I would have to count my rise over run. I'm going down 2 over 1, 2, 3, 4, 5. Now, again, this one is also a negative slope because the line is going downward. It's decreasing. So as I'm looking at line C, I have y equals mx plus b. M is your rise over run. The rise is 2 over 5. I cannot simplify this, but I do want to make sure that the slope is negative because it's going downward. And then b is your y-intercept, which is 4. That's where it crosses the y-axis. I plug these two variables into my original equation, right? Into here and here, and I have y equals negative 2/5 x minus 4. So if you can find those two things from the graph, you got yourself the equation. And finally, given the equation, can we do find the equation in point slope form given some material? So here, it's going to be important that we first find the slope for these two problems. I'm going to stick to the two colors that I used before. So for number 1, I'm going to do it for line B. I'm going to focus on this line. Okay, I'm going to find the slope first because slope tells me whether they're parallel or perpendicular. Okay, so I'm going to first find the slope, and we already did that earlier. We said the slope was 3 over 3. Because it was negative, we said m was equal to negative 1. Okay, now I'm interested in finding a line, if you look at number 1 here, a line parallel to B that also goes through the point 3, negative 2. So I can go to the graph if I wanted, and I can do that. I can just go to 3, negative 2. 1, 2, 3, negative 2. I want to find a line that's parallel to this one, and it goes through this new point. Now, since the slope is negative 1, I want to keep the slope the same. Okay, and go through that point right there. So because I'm looking for point slope, I'm going to write it in the form of y minus y1 equals m times x minus x1. Because I want the slopes to be parallel, I want the slope to stay the same. If you want a refresher on how do you know if the slope is the same or perpendicular, go watch my other video, 3.3, slopes of lines. And there I go over different examples and talk about how to find them. So if I want the same slope, I want to keep the same slope as line B that I highlighted over here. I want to keep the same slope and just change the point that I'm plugging in for x and for y. So I have y minus y1, which is negative 2, equals the slope. I want to keep it as the same slope as the previous line, negative 1 times x minus x1. The only thing I have to account for here is this minus a negative. It should change to a positive. So I'm going to change this to plus. And there's your equation. It's parallel because it has the same slope, and now it goes through that point, and this is in point slope form. The next one wants to be perpendicular. Perpendicular means that the slope is a negative reciprocal. So if I look at this other one, the line, I'm going to do this in red. I want them to be perpendicular. So I'm going to find first the slope down to over 1, 2, 3, 4, 5. The slope is negative 2/5, right? It's going down and 5 to the right. I want perpendicular slope. So I'm going to take the slope, I'm going to call this M1, negative 2/5, and the new slope, I'm going to call it M2. I'm going to flip the slope, 5 over 2, and I'm going to change the sign from negative to positive. This is the slope that I'm interested in. That slope will be perpendicular to this line. And now it has to go through these points, x1, y1. So I go to my formula, y minus y1 equals the slope that I want times x minus x1. The new slope is 5/2, right? Not negative 2/5, because I want it to be perpendicular. Y minus y1, that's a negative 4, equals the new slope times x minus x1, which is negative 2. These minus and negatives, I just have to change them to plus. And there's your formula. Y plus 4 equals 5/2 times x plus 2. For this particular problem, you'd have to know what it means to have parallel slopes and perpendicular slopes, and then write the equation given the information you have from the graph. I hope this has helped. Please let me know if you have any questions. Comment below. I can clarify some things for you. And as always, we'll calculate later.